Hello everyone, welcome to lesson 2 of Least Squares Approximation. So in lesson 1, we introduce the Least Squares Approximation and how we deal with the error. In this lesson, we are going to derive the constant a and b in g of x here, in the function g of x. Okay, so our aim is to find the constants a and b so that the error e is minimal. Okay, and we learned from our previous lesson that the sum of squared error e is equal to the summation of each I squared, right? But we said that our EI is equal to the actual value minus the approximate value. Okay, so when you do substitution, you're going to get this. Okay, but don't forget that our g of x is equal to a plus bx, which implies that our g of xi here will be a plus bxi. So when you do substitution, you're going to get our e to be this. Okay, now to find the extreme point of e, the partial derivative with respect to a and b must vanish. So what we are going to do here is to find the partial derivative with respect to a on both sides of the equation and equate it to 0. I will do the same for b. Okay, so this we use this symbol when we are dealing with partial derivative, right? Partial, right? So the partial derivative with respect to a on the left hand side is this, okay, and the partial derivative with respect to a on the right hand side is this. So you find the partial derivative with respect to a on both sides of the equation. Now, from calculus or from derivative or differentiation, we, if you can remember, if you are asked to differentiate something like x plus 4 all squared, what you do is, now these two come in front here, then you differentiate what is in the bracket. Here you are differentiating with respect to x. So you differentiate what is in the bracket with respect to x. Then you subtract the exponent by 1. Okay. So here you're going to get 2, right? Then if I differentiate what is in the bracket with respect to x, I'll get 1. Okay. Because when I differentiate x with respect to x, I'll get 1. 1. Then multiplying x plus 4. So I'll maintain what is in the bracket again. Then 2 minus 1. So I'm going to get 2x plus 4. Right. So you're going to apply the same principle here. Here we are having yi. So let me expand this one. Minus a minus bxi. Okay. All squared. And we are differentiating with respect to a. Okay. So we are going to get the 2 come here. So these 2 come front here. 2. Now, when you find the partial derivative, when you differentiate with respect to a, we treat for partial derivative, we treat the rest to be constant. Okay, yeah, so we treat the rest to be constant. So this one is constant, this one is constant, and the derivative of a constant is 0. Okay, that's when you differentiate a constant, you're going to get 0. So here is 0. Now if I differentiate negative a with respect to a, I'll get negative 1. Get it? And this one is also 0. Then I'll maintain the bracket again, minus a minus bxi, then 2 minus 1, which is 1. Okay, so at the end I'm going to get negative 2 multiplying whatever is in the brackets. You get it? So that's why we had this equation. Okay, all right. So when you divide through by negative 2, you are going to end up with this equation. And If you multiply through with the summation symbol, you're going to end up with this. Okay. So if you multiply through the if you multiply through with the summation symbol, you're going to get this. That is so summation of yi minus a minus bxi. Okay, that's it. So when I multiply through the summation symbol, I'm going to get this one. Okay. So let this one be our equation 1. Now, from basic property of summation, if you are to find the summation from I equal to 1 to n of a constant, so here our C is a constant. Okay. So means you're going to sum the C n times, which is the same as n multiplying C. Example, if we are to find the summation from I equal to 1 to 4 of 5, this means you have to sum 5 how many times? 4 times. So 5 plus 5 plus 5 plus 5, which is the same as 4 times 5, 20. You get it? So the summation of the constant here from I equal to 1 to n is the same as n multiplying the constant. So when we come here, we have the same thing here. So our a here is a constant. Okay. So we can write this one as na. Get it? Good. So when you write this one as na, our equation will turn to this. You get it? Okay, so from here, when you make summation of yi, the subjects, you are going to get this equation. And this equation is going to be our equation 2. So we are done with the partial derivative with respect to a. Now we are coming to do the partial derivative with respect to b. Okay. So we go to the same process that we did when we find the partial derivative with respect to a. Okay. So that's the so you find the partial derivative with respect to b on both sides of the equation. Then you also equate it to 0. And by here, you're going to get to multiplying what is in the bracket, multiply negative xi. So that's how we got it. Now we are having yi minus a minus bxi all squared. Don't forget that here we are differentiating with respect to what? B. Okay. And as a partial derivative, here when you are differentiating with respect to b, we treat the rest as a constant. Okay. And when you differentiate a constant, you get 0. Right? You get it. So the 2 will come in front here. Then you differentiate what it is in the bracket with respect to what? B. Now you can see here that this one is constant, this one is constant, they'll go to 0. We have a negative bxi. If I differentiate negative bxi with respect to b, I'll get negative xi. Then whatever is in the bracket will still be maintained. Okay. Then 2 minus 1 still give us 1. Because we subtract 1 from the power, the exponent. So that's how, or that's why we got this one. Okay, so now we have our 2, the negative x and multiply what's in the bracket. So we can bring the negative out from here to multiply the 2, and we get this one. Okay, and when you divide, so when you divide both sides of the equation by negative 2, and when you multiply through by the xi, you're going to get this equation. Okay, you're going to get this equation. All right. So let me show how we had it. So when you divide 2 by negative 2, you're going to end up getting a summation of, and sorry, So when after dividing 2 by -2, and you multiply 2 by the summation, you're going to get this one minus, as we had in the first part, this one, then minus summation of b xi. Then the xi you're multiplying. Okay. So still when I'm multiplying 2 by the xi, I'll get summation of xi yi minus the summation of axi minus summation of bxi what's squared. You get it? So here a is constant, I can bring it out. B is constant, I can bring it out. So at the end, I'm going to end up getting this equation. Okay, thank you. Okay, so here too, when you make the summation of xi, yi, the subjects, you are going to end up getting equation 3. All right. So equation 2 and equation 3. So that's our equation 2. Our equation 2 and equation 3 here. That's equation 3. They are called normal equations for straight line fitting. Okay. So equation 2 and equation 3 are called the normal equation for straight line fitting. Now, in matrix form, we have equation 2 and equation 3 to be this in matrix form. So you can see that equation 2 we have NA plus B summation of XI is equal to summation of YI, right? And equation 3 we have A summation of A summation of xi plus B summation of xi squared is equal to summation of xi yi. Okay, so I can represent this in a matrix form. So in matrix form, I'm going to get n summation of xi, summation of xi, summation of xi squared, then a b is equal to summation of yi, then summation of xi yi. Okay, so if I do my multiplication operation here, I'll end up getting this one back. Okay, so in matrix form, we are going to get this. But if you proceed to use either the method of substitution or the elimination, that's the simultaneous equation. So if you solve equation 2 and 3 simultaneously, you will end up getting A to be this and B to be this. Okay, but the work becomes much simpler when you use the matrix form. Yes, so that's all. So this is, please, you can try. Yeah, if you solve the equation 2 and 3 simultaneously, you end up getting A to be this and B to be this. And matrix form, you have this one. So in our next lesson, we solve examples. Okay, thank you very much.